In the previous section, we looked at materials that would be suitable to be used for a monocoque chassis. And in that process, we created this chart which showcases and compares these materials in terms of their lightweighting potential and their cost-saving potential. And we, of course, explored a couple of options that seem to be most optimal and suitable for this application. But looking at this chart, of course, the materials that would be of interest to us are the ones that are towards the bottom left corner of the chart. These are the ones that have the highest lightweighting potential and the highest cost-saving potential. But as you can see, there is actually a large gap in this section of the chart. There are no materials that are available in this gap, and you might be thinking that you may actually be able to produce and create materials that would fill this gap and that would have a better performance for this application. These materials could be multi-layer materials, they could be sandwich panels, cellular structures, and so on. So the question is there a tool within the software that would be able to help you in prototyping such a material? And the answer is yes. So within Selector, we have the synthesizer tool. And as you can see here, using analytical models that are available within the synthesizer tool, we are enabled to look into the performance of hybrid materials, including, as you can see, cellular structures, composites, sandwich panels, and multi-layer materials. And we are able to predict the properties of these structures. The potential benefits of these materials can then be studied by comparing these synthesized materials with the materials that are already available in the database of the software, and they are depicted, of course, in this chart, for example. And we can use visual charts and run material selection projects to see if these synthesized materials are more suitable for our application. In the early stages of design, the synthesizer tool can help to explore hybrid materials that may provide a better lightweighting and cost performance for a monocoque chassis, and fill in the hole that, as you can see, is available on the chart with potential materials of interest. So I'm going to use a sandwich panel analytical model that we have available and try to create materials that synthesize materials that may have better performance for this application. So we can, compare them with the materials available in the database. So here, when we click on the sandwich panel model, as you can see, the software asks us to fill in and populate the field that we have for materials that would be used for the face sheets of the sandwich panel, as well as its core. So for the face sheet, in this section, I'm going to be using one of the carbon fiber materials that we had identified as being one of the best performing materials for this application, and that is the epoxy matrix composite, which has a high strength carbon fiber as its second phase. So let's find this material for the face sheet. Let's go to browse. We can find this under hybrid materials, composites. We can go into the polymer matrix composites, the epoxy folder, carbon fiber filled composites, and we are interested in the unidirectional prepreg and the unidirectional layup. So let's click on that. So now we have the face sheet material identified. For the core of the sandwich panel, I'm going to use an aluminium honeycomb, which is regularly used for these type of applications. And to find that, we can click on Browse. Again, under the hybrid category of materials, we can find the honeycomb folder, and there I'm going to go to the expanded folder, longitudinal properties of these honeycombs I'm interested in. We can go into aluminium, 3003 alloy, And I'm going to go with the 0.022 relative density or specific density of this type of alloy, the Horic conversion of the alloy. Let's click on that. So we have the core material identified as well. Then we are asked to populate the thickness of the face sheets as well as the thickness of the core material. So as you can see, we are able to provide a range, and I'm going to look into a range of thickness values between 0.5 and 5 millimeter, and I'm going to ask the software to create 5 values or choose 5 values within this range when creating these synthesized materials. And for the core thickness, I'm going to ask the software to look into a range of between 10 to 20 millimeters, and again create 5 values or choose 5 values within this range when creating these materials. The software also asks us to identify the support and load conditions, and as you can see, there are different scenarios that we can go with. For our scenario, monocoque chassis, I'm going to go with the built-in ends with a central load, but of course, any of the other ones that is more suitable, we have the option to choose them. The span of the panel that would be used for the monocoque chassis, I'm going to look into a 1 meter span panel, and finally we need to essentially name the face sheet and the cores being used here. So I'm going to for the face sheets, I'm going to use epoxy high strength carbon. And for the core, I'm going to put aluminium honeycomb. There you go. So when we click on create and finish, you can see these synthesized materials that we just created appearing on the chart. Like any other material on the chart, we can click and drag to label them, and easily we can identify which of these materials sits where on the chart. So as you can see, obviously, these synthesized materials seem like they have better performance for this application compared to all the other materials that are on the chart. And the best performing synthesized material seems to be this sandwich panel, which has a epoxy matrix composite with high strength carbon fiber as its face sheets with a thickness of 0.889 and a 10 millimeter aluminium honeycomb at its core. So we can double click on its label. And the datasheet for this synthesized material pops up, and we can see the estimated properties of this material. So we have the price, the density, some mechanical properties, thermal properties, electrical and environmental attributes of these this synthesized materials available to us. And at the bottom of the data sheet, we have some of the choices that we had made for this synthesized materials to be created. So that's essentially how the synthesizer can be helpful if you're trying to prototype a new hybrid structure, a new composite, new sandwich panel. This will allow you that in the early stages of design, before you have done any physical experiments or physical manufacturing of this material, you would have an inclination of what the properties of the material would be, and there you can choose some of the better options when creating these materials. So you know roughly what thickness would make sense for this application, what material would make sense. And of course, in terms of the core of the material, I simply chose to use the aluminium honeycomb, but in a real world material selection project, of course, when you're looking into the synthesizer tool, it's best to run a simulation, a material selection project for the face sheet material, and run a separate material selection project for the essentially core of the sandwich panel, and that would provide you with best results. So that's how the synthesizer would be able to help you before prototyping any new materials and compare them visually with the materials that are available on the chart. So this sandwich panel seem to be the best choice for as a material that can be used for a monocoque chassis when we are designing our car. All right, let's move on to the next stage.